Okay, guys, we are on part 2 of our memory training. So remember the last lesson did the confidence interval for paired differences, and this one is going to do the hypothesis test. It's your last lesson. Yay! Oh, you are so there. Okay, so let's get through this, and then you can celebrate, and you've learned everything new at this point. All you got to do is study after this one. Suppose that 32 seniors were randomly selected to try both memory strategies. Each student calculated the difference in the number of words, strategy 2 minus strategy 1. The mean of the differences was, I don't know what I was supposed to say, was calculated, and the standard deviation of the differences is blank. Oh, I don't have the numbers there. Okay, I'm going to have to grab those numbers. Looks like the mean, sorry, it's not showing up on this, of the differences was 1.5. And the standard deviation is, here, I'll write them off to the side here. N is 32, mean is 1.5, standard deviation is 2.7. Sorry, it didn't list it on that page there, but there we go. We got our numbers. Did these data give convincing evidence that strategy 2 improves memory at the significance level of 0.05? Okay, so we're running through a hypothesis test. Hopefully you can hear the wording where it says convincing evidence. Do we have evidence? And our significance level was listed for us. Let's go through and run through what we know. We are looking at the mean of our differences, which is the true mean difference in remembered words. Our statistic is going to be x bar d, which we know to be 1.5 because they told us that, or we're supposed to. Our significance level is 0.05. They told us that. And then our null and alternative hypothesis, we have to do same thing, no difference, and then there is a difference showing improvement, but we're just going to do it with mu d. So to show there's no difference, it's just mu d is equal to 0. That when we actually subtracted the two original data values, we got 0, no difference. And our alternative here would be that there is a difference. And if we want to show that strategy 2 showed improvement, then that means we want to show that when we did strategy 2 minus 1, if strategy 2 was better, then we would have our bigger number minus our smaller number, which means we would have numbers that are positive. Be careful on that. When we did this one before, we did strategy 1 minus strategy 2 and got negative values. So here they switched it up on you. This should give you positive values if strategy 2 is better. Okay, so be careful. Plan it out. Name of procedure. We have a single sample t-test for paired data. Be sure you're not just writing a single sample t-test. You know it's paired, know that it's for differences, something there to indicate that it's not just a regular one sample t. Okay, checking our conditions. We have randomly assigned seniors, or randomly selected, I guess I should say. Our 10% condition, we have paired data, and we are looking at approximately normal. For our distribution, and since we don't have the data, I'm very thankful that we have a sample size of 32. That's greater than or equal to 30, which means the central limit theorem tells us that we are good to go in assuming that our distribution will be approximately normal in shape. Okay, let's do our problem. Our mean and standard deviation for our picture is going to be our mean of our null, and our standard deviation has to be adjusted by dividing by the square root of n. That's going to be 2.7 divided by the square root of 32, which should give us a value of 0.477. That allows us to draw the distribution with a mean of 0 and a standard deviation of 0.48. We are looking at trying to find our t-test statistic for an improvement. So you can label this with your value for the actual difference of your means, or you can just wait and put your t-score on there. It's up to you. Okay, so our t-test statistic is going to be the statistic minus the null hypothesis, minus our population's value divided by standard deviation. So it's going to be x bar d minus mu d divided by SD over root n. And that means it's going to be the 1.5 minus 0 divided by 0.477. That means t is going to be plus or minus, oh, no, just kidding, just plus. T is going to be 3.14, which 3 standard deviations above the mean is going to be all the way over here. Not a lot of area left under that curve. We have a p-value. If we calculate this, remember on your calculator, you can run this as a test. Go to your tests, find your single sample one. I think it was number 8, if I remember correctly. And, oh no, that was for our interval. This one is a test. So for a test, it's not going to be number 8. It is going to be number 2. Just a t-test. You are going to have to enter the statistics because we don't have the data on this one. So the statistics is that our null is 0. Our mean is 1.5. Standard deviation of our original sample was 2.7. That's what they told us. And there was a sample size of 32. Remember, you don't type in the adjusted standard deviation. You type in the original standard deviation of that single sample, because the calculator will do the adjustments when it does the whole thing. We do have a greater than situation. We're trying to see if there was an increase in strategy 2. And so run your calculations. Remember, this is your greater than situation there. We have a p-value of 0.0018. You could also do normal CDF. No, not normal. My goodness. You could also do TCDF of that value up to something really big with your degrees of freedom to find that area under the curve as well. And try to remember on this to say what your degrees of freedom are. It didn't spit it out on our calculator because we have a single sample. So with 32 were in our sample, we have a degree of freedom of 31. Remember to write it down because technically it's used and your calculator doesn't show it. So I boxed it in, put a little star there. For some of you, that's going to be a tough one to remember. So you really need to make sure when you do your book work that you practice it accurately, and you're making sure you write it down every time. Make it a habit, then you won't forget it. Okay, so our conclusion is going to be that at the 5% significance level, we look at our p-value in comparison to our significance level. And it is, in fact, much smaller than our significance level. So that shows us that we have something that is statistically significant in the sample that we saw. So we are going to reject the null. Okay, So at the 5% significance level, we do have evidence that the true mean difference and then let's go back and look at our wording up here. Let's see if they gave us some nice wording. Evidence that strategy 2 improves memory. Okay, so we do have evidence that the true mean difference in remembered words shows an improvement when using strategy 2 versus strategy 1. Okay. So there's lots of different ways to word that, but that one at least kind of sounds like normal English description. Your conclusion is meant to tell your reader what you found, and you want it to sound normal because the rest of it's the mathy part. So we try to make the conclusion sound something a little bit of what we know. Remember that you can also describe what that p-value actually means. You should be able to tell me that if we were assuming there was no difference, in the two strategies, then we would have a 0.0018 probability of getting a sample mean difference of 1.5 or less just by chance. The p-value is the probability that our sample happened just by chance. That was such a small probability of seeing this sample happen simply by chance. That's why it was statistically significant. Okay. So last example problem, there was your paired hypothesis test. Let's go through and fill in our big ideas, and then we'll do the check for understanding. So remember, when we do a single sample t-test, we are looking for our t being calculated from the mean of our differences minus the population difference divided by standard deviation over the square root of n. You do need to make sure that you list your degrees of freedom on this one because it's not listed for you, and we are still talking about the true mean difference in the end when we word our conclusions and stuff. Okay, so the other thing that I really want you to think about at this point is it 1 or 2 samples? And where to go from that. So when we had 1 sample, that's where we went with the matched pairs. And we subtracted, and then we did the average. When we had 2 samples, that was when we had 2 separate groups that were independent of each other. And where we found the average of them separately and then took the difference of their averages. So I just wanted you to see the wording of the order of the math that we actually do. We find the differences for one sample paired. We find the differences of each individual data value, and then we take that average. When we had 2 samples of independent groups representing 2 different populations, we found the average of each of those data sets first, Then we took the difference of those averages. So hopefully that helps you clarify how this is comparing to the 2-sample one compared to a single sample matched or paired one. Okay. I know that's going to be hard for some of you guys to really filter all of this through. So again, you might want to read through it in the textbook. It has a lot of good strategies and pointers to help you remember stuff. Remember, I said from the beginning, our book is actually quite user-friendly for you guys to read and understand. So if you're struggling with this section and understanding what's what, then maybe go back and read through the book, and it might help concrete some of these ideas for you. Okay. Pause this one, and in the check for understanding, this is the perfect check for understanding at this point. It's walking us through just situations, and you have to be able to tell what type of procedure gets used. This is the part where I said it's going to come down to not the math, but can you tell what type of problem you're given with just the situation? Okay, so pause it, try and do it first, and then come back and rewatch it and see how you did. Let's run through these and get some answers. So in each of the following settings, decide whether you should use 2-sample T procedures to perform inference about a difference in means or paired T procedures to perform inference about a mean difference. Explain your choice. Before exiting the water, scuba divers remove their fins. A maker of scuba equipment advertises a new style of fins that's supposed to be faster to remove. A consumer advocacy group suspects that the time to remove the new fins may be no different than the time required to remove the old fins, on average. 20 experienced scuba divers are recruited to test the new fins. Each diver flips a coin to determine if they wear the new fin on the left foot and the old fin on the right foot, or vice versa. The time to remove each type of fin is recorded for every diver. So think about populations. Where are our samples coming from? Do we have 2 populations that we're trying to find the difference in? Or do we have 1 population that we're trying to find the average difference of? Okay. In this situation, this should be a paired T procedure, because we have 2 measurements taken from 1 sample. And they are representing 1 population. Okay? Part B. To study the health of aquatic life, the scientists gathered a random sample of 60 white piranha fish from a tributary of the Amazon River during 1 year. The average length of these fish was compared to a random sample of 82 white piranha from the same tributary a decade ago. So, are you comparing 1 population and finding the difference within that population? Or are you looking at 2 different populations and comparing their averages, their differences? Did you think about it? Okay, so for this one, you're looking at 2 different samples. So you were looking at a 2-sample T. Okay. 2 samples, different decades. Just to help you remember, when you have a paired T, you're finding the mean difference. And when you have a 2-sample T, you're finding the difference of the means. Okay, last one, part C. Here's the one where now it could be either or. Can a wetsuit deter shark? I don't know how to say that. Shark attacks. A researcher has designed a new wetsuit with color variations that are suspected to deter shark attacks. To test this idea, she fills 2 identical drums with bait and covers one in the standard black neoprene wetsuit and the other in the new suit. Over a period of 1 week, she selects 16 two-hour time periods and randomly assigns 8 of them to the drum in the black wetsuit. The other 8 are assigned to the drum with the new suit. During each time period, the appropriate drum is submerged in water that sharks frequent, and the number of times a shark bites the drum is recorded. Okay, so what do you think? Do you have one group that was measured twice, or do you have 2 separate groups being measured? Hopefully you said 2 sample T. If you did, you got it. This is, in fact, a 2 sample T procedure. We have 2 groups of 8. Each being tested, which means we again have a difference of 2 means. Oops, difference is spelled with an I. Okay, so hopefully that helped clarify a little bit of how you're going to be able to tell if it's paired and you do a 1T test, or if it's not paired, if they're independent groups and you do a 2 sample T test. Again, work through the book problems on this. The Khan Academy didn't have a good one that compared these two, so you're at the end. Meet me on office hours if you have any questions. And then after this is your quiz, and then we're just going to start studying. So again, be sure to meet me on office hours if you have questions up until this point. And I look forward to you guys celebrating the end. Yay! Good luck.